back to my channel. In this tutorial, I will teach you how to transform a UML class diagram to a Java application based on Spring Boot and Spring Data JPA. We will see together how to connect to a database, how to configure a project to connect to this database or this data source. Also, we will go through all the steps to create the table, create the columns, adding some specific requirements, like for example, if you have a field that requires or that should only accept specific values or like predefined values, like for example, if we talk about user roles, having a role admin, role user, and so on and so forth, I will show you how to implement this and how to fulfill this requirement. My name is Ali, I'm a senior software engineer and I do videos every week. So if you're new to my channel, just go ahead and subscribe so you get notifications and you get notified when a new video is released. Also, go ahead and join our community and be part of the greatest developers community that we are building right now. Before we dive into the code, just take 3 seconds and smash the like button so you give me a thumbs up so I can continue on recording this video for you guys. So just take only 3 seconds. No, actually it's not 3 seconds, just 1 second. Just go ahead and click on the like button and give me this thumbs up. So now let's go ahead and dive into the code. Before diving into the code, let's first understand what we want to do. Let me explain to you what this video is about. Here, imagine we want to implement or we want to create a database with several tables and we want to store data there. Now we have our database and here we want to have our employee table inside or into this database. And this employee table is characterized with a primary key called ID, an identifier which is a unique identifier of this employee, a first name and last name which they should not be null, an email which also should be unique, so we should not have 2 employees with the same email, and here we have also a birth date of type date. And here also we want to assign a role to this employee, and this employee can have whether a role user or a role admin. So what are the possibilities we have here within this database, or how can we manipulate data within this database? So we can first recruit a database administrator and he can perform all the SQL queries and we can store the data and so on and so forth. Also, what we can do, we can create some Excel sheet or some scripts and so on and so forth just to persist and read the data. Also, we have the other possibility, and this is why we are here today. We can create an application. We can create, for example, Java or Spring application that will communicate with our database and it will perform many actions like saving, deleting, reading the data, and so on and so forth. Now, when we move on to designing our application, the first thing that we need to think about is to have a representation or a Java representation for each table. And here, let me show you this one. So here we have our entity, and this is what we call entity in a Java code. And here we have an entity, and as you can see, this is a representation of the employee. And here what I did is I provided the same attributes. As you can see, here we have the ID, last name, first name, and so on and so forth. And we also have the identifier. This is going to be the unique ID of the table. Then, and here we have, this is our application, and this is where Spring Data JPA comes. So the application will use this entity model or this entity object to communicate with the database. Why we need to do that? We need to do this just in order to avoid writing all the SQL queries manually. And for example, if we want to insert the data, like we need to do or we need to prepare an SQL query like insert into employee, and then we need to provide all the fields that we have like first name, last name, and so on and so forth, and then we need to provide the values. And imagine one day we want to extend or we want to remove some fields from our table or tables, generally speaking. So in this case, I have to go and update all the queries that we already wrote manually. But if we use an entity or if we use a model that represents our tables or our table, in this case it's going to be the employee table. So in this case, all we need to do is to update this guy and of course perform updates to the table itself. So as I explained here, what we will do, first of all, we will create our database, and then we can whether manually create this employee table, or we can also delegate this to Spring Data GPA, and the table will be automatically created, and we will see that. Next, we need to create the entity, of course, because we will develop this Java application or this small Java application. And yeah, so as I mentioned, first we need to create the entity and then configure our application to connect to the database that we created in the first step. And then we will see how to manipulate or how to use the properties and to use the strength of Spring Data GPA to have this final table as we wanted here. So like having a unique identifier, a non-null first name and last name, unique email, a date for the birth date, and also having a role user or a role admin as values for the role. So we cannot or we should not allow a different value for the employee role. So that's it, and let's go ahead and dive into code. The next step is, as always, creating a new Spring Boot project. So you know me and you know my preferred way to create this. So first of all, let's dive and go to start.spring.io or the Spring Initializer website, and let's select the properties and create our new Spring Boot project. So as usual, it's going to be a Maven project instead of Gradle because I prefer Maven. Java as programming language, as always. Sure, of course, Java. Next, so we now at this time, or at the time when I'm recording this video, is 2.7.4. The 2.7.5 is still a snapshot, and soon, or the end of November, not the end, not exactly the end, but in November, they will release the Spring 3.0.0, and I'm gonna make a video for you guys about all the changes or what's happening with it within this new version. This is gonna be really, really amazing. And also I can create a migration guide. So if you are using a different application or a different, no, not application, but if you are using a different version of Spring Boot, so I will give you a complete guide to migrate from the old Spring versions to the 3.0.0. All right. Now let's go ahead and update our project metadata. So here it's gonna be, as always, let's call it com.workshop.boali, and here demo for Spring Boot data JPA. So this is going to be the package name. We want a jar packaging, and of course Java 17. So one thing which is really, really important here, just try to get used to Java 17. First of all, with the new features, Second, when you create Spring Boot projects, go ahead and select Java 17. Also update your environments and so on and so forth. Why? Because because Spring 3.0.0 will no longer support previous versions or like lower versions. It's going to be 17 or more or higher. So now let's go ahead and add the dependencies. So I will need the Lombok first, and then I will use the Spring Data JPA. So, and this is, let me add Spring Web. Maybe we need it, or we want to add something like that, but I don't think so, but let's just do it. So here, these are the dependencies that we will use for our project, and all we need to do now is just hit the generate button, and you will also have the code available on my GitHub repository. All right, so let's generate the code and let's move to the next part. Now I opened our generated project using my IntelliJ. This is the IDE I prefer working with, so I highly recommend it. But first, let's go ahead and configure or connect to our database. So to do so, if you have IntelliJ, the full version, not the community, you will have a database tab or panel here where you can perform a connect or a connection to your database. So you will create a data source in here, and you will have all the database in the same place. I prefer doing this because I want to have everything available at a glance in the same place. But if I have the solution for you, like you will say we have the community version, but now I will give you the solution how you can do this. So before going there, let me also see the options. For example, if you are using MySQL database, so you can use the PHP MyAdmin to access the database, or if you want to use the tool I'm gonna tell you about right now, it's up to you guys. So for me, I'm gonna use a PostgreSQL database, and as I mentioned, I will add my data source in here. But for you, if you don't have the full version, or if you don't have, for example, the PG admin application, or you don't want to use it, or and so on and so forth, so there is a really cool alternative, which is this guy. So it's a tool called dbeaver, and you can download it, and also to create or to add a data source. It's also the same thing, the exact same thing, the steps that I will show you right now. So just if you need it, go ahead and download dbeaver for yourself. Okay, so to add a data source, here click on this plus, new, and then data source, and you can select the database that you want to use. Like you have from Amazon Redshift till so many options. And let's make this short. I'm gonna select PostgreSQL, and here all I need to provide, it's already provided, and everything is almost ready for me because I'm always using this. So here I have the PostgreSQL driver, and the connection type is default. So for example, if this is the first time for you, you will have a link here telling you to download the driver, or it's gonna be a pop-up down here. I just forgot. So first of all, you need to go ahead and download the driver, and then you need to provide the host and the port. If you didn't change, or if you did not customize anything while installing PostgreSQL, it's going to be exactly the same thing. Otherwise, for example, if you change the port, or if you change the host, and so on and so forth, so just go ahead and provide the correct information. Next, you need to provide the authentication. So for me, when I installed my PostgreSQL, I did not provide any user or password because I just don't want to do this every time. Yeah, and that's it. Also, just try to remember, and I will show you how to get this URL next. So now once everything is ready, just go ahead and click on test connection, and this is gonna try to test the connection to your database. So if everything is okay, you will have this succeeded, and all you need to do, click apply and okay. And here it's gonna just take a few seconds to pop up, and here you will have, or here you have your database or your source, data source. So next step, and here we have nothing in this public, we don't have any database yet. So let's go ahead and create a database for this workshop. So click on new and then database. Just give it a name. Let's call it workshop, or let's call it Alibu _ workshop shops, because we will have so many workshops in the future. So I'm gonna call my database Alibu workshops. I will just click OK, and here you will have this Alibu workshops. And now what we can do, we can click on this, just remove the default and keep only the Alibu workshops. And you will have here all the schemas, but we need to select them, whether you do all or just select the public. The public is totally sufficient. So here you will have the public schema, and inside the public schema we will have all the tables that will be created later on. So that's it. The next step, we will configure our project to connect to the database we just created. So let's go ahead and do it. After connecting to the database, what we need to do now is to configure the connection, or like to tell our application to connect to the database we just created. The first thing is, let's go ahead and use YAML representation. So here you can use YAML or YML. All right, let's open our project. Now to connect to the database, we need to provide few properties, and because we have in our pom.xml file, we have this dependency, the Spring Boot started data JPA. So we will have an auto configuration to connect to our database, but we need to provide the minimum required information, like the URL, username, password, and we can also provide or override some other properties. So let's go ahead and do this. So here what we need to provide is spring dot another typo, spring dot data source dot URL, the first one, and as you can see, when you choose it, it's automatically formatted to the YAML representation. So this one, as I mentioned when we were connecting to the database, that you need this string, and here when you right click and show the properties, you will find it here. So this is our connection string. So this is going to be our URL, but the database, as we mentioned, it's Alibu _ workshops. Let me close this. So this is our URL. Now we need to provide other information. We forgot one thing. We forgot to add the driver class name, but we will add this dependency right away. So we want to connect to a database, so we need to provide the dependency for that. So it's PostgreSQL and org.PostgreSQL. This is what we need. Now let's just refresh or reload the dependencies by clicking on that small icon, and then Maven is resolving the applications. It will be ready in a few seconds. Let's go back and finish our implementation. So for the driver class name, we'll just go back and finish it later on. Also here to provide the username. So in my case, username is empty. Same for password. Password is also empty. I don't have a word. So here for the driver class name, it's now, or it should be now ready. So you can do a control space to have this auto completion, or you can just type it yourself. It's org.postgresql.driver. So now this is the connection to our database. We provided all the necessary information to connect to our database. Now we need to add some GPA configuration. So here, what we have first, we have our GPA, and then we have another option, which is Hibernate. So here we will provide some Hibernate properties. And here we have a property called, I guess you all know it, it's the DDL auto. I will explain this in details. So this DDL auto means what we want to do within our database when the application starts. And here we have 5 options. The first one, let's start from the bottom to the top. So the first one is none. So we want to disable the DDL handling. So we want to do nothing when the application starts. Next one is create drop. This one will create and then destroy the schema at the end of the session. This one we need it, or you can use it when you are first bootstrapping, or when you are first still setting up the application and you don't have the final schema. So like you're doing iterations and iterations just to have the final schema or the final tables. Create, this one, it will every time create a new schema and destroy the previous data. So you need really to be careful with this one. Because, for example, if you have your schema ready and you also inserted or have some test data or some data in the database, and even imagine you have a production database and you use this create property, it will just go and destroy everything and recreate the schema. So you really need to be careful with that. Next one, it's validate. So all it will do, it will do no changes, but it will just validate the schema. So it will compare the Java representation within the database tables or the database representation. And if everything is fine, like the application will start. Otherwise, it will tell you, or it will raise an exception telling that, for example, the Java is missing something or had something in plus, and vice versa. The last one, it's the update. So this one will update the schema if necessary. So if needed, it will update the schema. And one thing which is really important that I found out, that the update will not remove extra fields. So for example, if you have five fields in your table and you remove one and you restart your application, in the table you will have always 5 fields. It will not remove any fields. So you need really to be careful what to choose. But what I really recommend is using none, and use another tool which we will see together to handle or to do all the database migrations. But for now, we're still in learning purposes. So let's choose create. So this is the DDL auto. Also, we can provide something. Let's show the SQL. Also, we can, it's Spring GPA properties, and then we have a property called format SQL. As we can see here, we can set it to true, and this one will allow formatting our SQL queries. So it's going to be just better to read later on. So also what we can provide later on, or like within all the Hibernate, sorry, not the Hibernate, but the GPA, because here indentation is really important. So at this level, it's gpa.hibernate. This one GPA is .hibernate.ddl auto, and this one is gpa.show SQL properties, and so on and so forth. So now we can also provide the database. It's just, I can show you the auto completion database, and in this one, like, you can provide which database you want to use. So it's gonna help much more GPA to perform or to create the correct SQL queries. Also, we can, if you want to, you can also provide the database platform. So this is to provide or to tell Hibernate which dialect to use. So it's org.hibernate.dialect.PostgreSQL dialect. So if this is, for example, if you make a typo, the application will not start. So now we have our application, and here the database is wrong. It's Alibu, and here it's PostgreSQL dialect. Now, so our application is ready to use and correctly configured. Let's move on and create our entity, and let's move and understand what we need to do step by step. What we need to do now is to create the Java representation of this employee table, which is this entity as we have here in our diagram. So let's go ahead and create a package. Let's call it models, and within this package we will create an employee class, Java class. In here we will have the attributes like the private string identifier. Also, we have a string first name, last name here. We have a string email, and we have local date as birth date, and finally we have a string row. So this is the representation of our table in the database. Now we need to generate getters and setters because Spring will need this. So let's use Lombok, and here we can use the getter and also to use setter. And if you want to have the all args constructor, always think about adding the no args constructor. So in this way, we created our Java representation for this employee table. Let's see in the next steps how we can transform this employee into an entity. The question now is how to tell Spring Data JPA that this is an entity. And the answer is already in the question itself. So we need here to add an entity annotation, and here you need really to be careful that this entity comes from the JavaX persistence package. If you have a different entity from a different package, for example this one which comes from the org hibernate annotations, so you really need to be careful about this. So you should always import the correct one. And here, when we add this entity, the first change that we can see is we have this icon popping up here, and this icon is telling that we have, or like this is a table representation into a database or inside a database. And also let's jump quickly and read the documentation of this entity. So here it says that specifies that the class is an entity. This annotation is applied to the entity class. So like simply this will tell Spring Data JPA, or let's just shortcut it to Spring. This will tell Spring that this class is an entity. And also let's go back here, and we have here one small issue. So it says that persistent entity employee should have a primary key. So to have the full representation, we need to tell Spring that we have an entity, and this is the ID for this entity, and this is exactly as we have here. So in this table we have a primary key and we called it ID, but in the entity when we created we did not add this one, because I did not add it in purpose, just to show you that when you use the entity annotation you should or you must provide an ID attribute with that. So let's move on and add the attribute. So here always avoid using primitive types like ints, longs, and so on and so forth. Always think about using the wrappers. So for example, integers or longs and so on and so forth. Why? Because simply the default value of the wrapper is null, and the default value of the primitive values is, for example, for int is 0, for long is also 0, and so on and so forth. So always think about using the wrapper. Now you can also have string, by the way, as an ID, or like you can create your own ID. And this is something we can, or maybe we will see in a different video. So now to tell Spring that this is an ID, all we need to do is add this ID annotation. And always the ID or this annotation comes from the same package as the entity, which is the JavaX persistence. So now this error should be gone right now. And yeah, exact. So here you see that all these attributes or all these fields we have right here, now they have this really nice icon which is telling that this is an attribute, and this one it comes with this key here just to tell that this is a primary key of this entity class. So now the question is, how do we want to handle this ID generation? Like, is it up to us to, for example, it's an integer, and is it up to us to always increment this ID by 1 or by a specific value and insert it into the database, or there is a way to do this in a simpler way using the power of Spring Data JPA? So let's see that. To make this field or this primary key auto-generated, there is an annotation called generated value. And this generated value, it will mention that this ID will be auto-generated and auto-incremented. And this generated value, let's have a quick look on it. So it has two attributes. And the first one is the strategy, and it's of type generation type. And the second one is the generator. So let's first go ahead and see the strategies, or let's see how we can use the strategy. So here we can provide the strategy, and in here we have 4 options. So the first one is generation type.auto, and auto, this means that we will delegate this operation to Hibernate or to Spring Data JPA to detect what is the best strategy to generate the data or to generate the ID. And this will check within the database what is the best strategy. And for example, if you are using PostgreSQL, it will automatically choose a sequence, and it will create automatically a sequence for that. For example, if you are using MySQL database, it will create a table for that, and the strategy will be table generation type.table. So let's go through the 3 different types. So now we understand what auto stands for. The identity means that Hibernate or Spring Data JPA will use an identity column for the unicity and generating the ID. Sequence, this means that it will create a sequence to generate the ID. So this one we might explain it in a different time or in a different video, what are sequence, or like we can also have a video or a course about SQL. The next one is generation type table. Table, as I mentioned, Hibernate will create a table, like an extra table within our database, and that this table will contain one column, which is the next value, and every time it will query this table to get the next value and also update it. So this table is not updatable or cannot be updatable by us, and it's always in read-only mode. So for me, what I always suggest or propose, try to or make it always auto and let Hibernate choose the best strategy for you. Okay, so this is the first attribute. Let's say it's auto, and then we have the generator. Here, for this generator, for example, if you want to use explicitly sequence, here you can, for example, create yourself your sequence, and you tell this is my sequence, or like this is the sequence name to use, or the generator name to use. But here what I recommend, as I mentioned, just leave it to auto, and because auto is the default value for this strategy, so we can completely remove all of this. So having only the annotation generated value is totally sufficient for us. Okay, so this is how we can make this ID auto generated, and it will be automatically handled by Hibernate. Let's now move on or go ahead and check how we can implement or how we can ensure that we have a unique identifier and non-null first name, last name, and unique email, and so on and so forth. And also we will see how we can make the role accept only one of these values, role user and role admin. In order to achieve this characteristics, having unique identifier, non-null first name and last name, there is one annotation that we can use, which is this one. It's called colon annotation, and as always it should be from the same package. It's always from Java Persistence, JavaX Persistence. Let me remove this one. We don't need it anymore. And this colon, like, it has so many properties. And for example, we have a name and the default is empty, and when we don't, or if we don't want to specify the name attribute, automatically the colon name or the attribute name in the Java class will be used as a name. But before doing that, let's just go ahead and start our application and see. Just enable processing and see what will happen in our database. So the application is started. Now I will open the database and click on this public and then refresh. Now we should see our table created. So here, let's first explain what happened. So here we have this table which was created, and now it's called the employee. And also, as I mentioned here, we used the generated value with an auto strategy. And Hibernate, he detected that the best strategy with PostgreSQL is using a sequence. So like, he created a sequence and he called it Hibernate sequence. So you can create, for example, we can, if you want to have a custom name or a custom sequence, you can just create yours and provide it in here. This is something a bit somehow, or let's say a bit advanced, and we will see it in details in a different course. So let's go ahead and check the columns here. So here we have the ID, birth date, email, first name, and so on and so forth. Now if I try to open the data, okay, so let's choose this option, generate DDL to query console. And here we see this is the SQL script. So here we have this ID of type integer, which is not null because it's an ID, and also it's a primary key. But for the rest of the attributes, they were just declared. For example, here it's data, and here it's just a varchar, meaning this is string, and the length is 255. But here we see that we can set or this can accept null value. So now what we want to do is to prevent this, and this email can also accept duplicate values. So let's go ahead and do this. So as we mentioned before, we have this colon annotation, and also one thing worth mentioning. So if you see the columns here, if each column here represents or has exactly the same name. So for example, let's see what will happen if we give it a different name. And here I'm just gonna call it employee underscore identifier. Oops, this is not identifier, this is a new word. Alright, so this is the name. Also, I want to tell that this identifier should not be nullable. So we have an attribute called nullable false. And if you want to have a look on all the attributes, all you need to do is just command click or control click on the annotation, and you will find all the attributes with the documentation. Alright, so let's restart the application and see the changes that will be or that will impact this identifier attribute. So I start the application, and then I will just go ahead and refresh this table, and let's see what will happen here. So we still have employee, the columns. So here we see that we no longer have a column called identifier, but we have an employee identifier. And also you see this small dot right here. This means that this is a unique identifier. So here, if I go ahead and again go to SQL scripts and choose, let me do it here, SQL scripts, and then generate the DL to query console, we see that here this is the name, and we automatically added this not null, means this employee identifier is no longer null. Okay, so let's go back and continue. Now we can just remove this name because we don't need it. And also there is something else that we wanted to add, or we have it as a requirement, which is, let me zoom in a bit, which is that this identifier should be unique. And here we also have a unique attribute or unique property, and by default it's false. By default it's not unique, but we can set also this identifier to unique. I'm gonna restart the application, and I want to show you the changes. So the application started. I'm gonna refresh again, and let's see the changes. So now we have this identifier, and you see now we have a blue part, or the icon contains some blue color. This means that the icon, or this means that this guy is unique. So now I'm gonna select the same option, generate DDL to query console, and here, as you can see, for the identifier we created a constraint, and this is the constraint name or ID. It's something unique, and here we added also this unique keyword. This means we cannot insert two lines into the employee table containing the same identifier. So for example, if our identifier is 1234 underscore Alibu, for example, so we cannot have two employees with the same identifier. Okay, so this is something. Also, let's go back here. So now we have this identifier which is unique, which is also not null, And let's do the same for first name, last name, email, and birth date. So we can, like this, we can ensure that we have the correct one. So here it's just a colon, and nullable, it's gonna be false because this is what we need. Let me close this and make it bigger for you. Yeah, I'm gonna duplicate this. It's the same for the email, and here I will just add unique false, unique true. I want the email to be unique. Now we fulfilled the requirements for identifier, first name, last name, email, and birth date. And now we want to deal with the role. So this means that for this role, I wanted to have only one value of two possible values, which is role user and role admin. And this is what we will see in just a few seconds, how we can do this. All right. So for this column role, we want it to be whether a role admin or role user, and we don't want to accept extra values. Hibernate give us really the opportunity and the possibility to do so. So for this one, we will go ahead and create an enum within the same package. So here, make sure you select enum and give it, for example, an employee enum. So, sorry, not employee enum, but employee role. Let's just call it employee role. And in this enum, we will have a role user and role underscore admin. So we have two roles here. One is user and one is admin. So now we are going to fulfill the requirements of the role attribute. So here, instead of having a string type, we will use this employee role as type. Now let's see how we can tell Spring that this is an enum and we want to use a specific thing for this one. We have an annotations called enumerated, and this enumerated, it's coming from the JavaX persistence as always, so make sure you import the right one. I will just go and let's try to see what this enumerated does. So here we see that the value, we have a value here, and this one is optional, of course, and the type used in mapping an enum type. So if we use an enum, what's going on? Okay, so if we use an enum type within our entity, so we have a default enum type here, which is called value, and the default is ordinal. And ordinal means that this is gonna be a numeric or a digital or an int value. For example, in this one it will be role user or role admin. So also we have another type. Let's go here. Here ordinal, it says that persist enumerated type property or field as an integer. So if we choose, this is the default value, so the persistence will be an integer. So even here we have this role user and role admin, it's going to be by default 1 and 2, 1 for the first one and 2 value for the second one. But we can customize this one and we can force it to be a different type. So if we use this, it's going to be persist enumerated type the property or field as a string. So like this, if we always use our application, so if we always use our application to persist the data or the employee data, it will be always this enum type. Let's go back here and add this property. And here we have the options of ordinal or string. And here, because for the role we decided that we wanted to have whether the role string or the role admin, so all we need to do is to give it this value, enumtype.string, and it will be persisted as a string. I will just restart the application and check the changes. So the application started. I will go ahead and refresh, and let's check the changes. So again, I will open the DDL of this table, but there is one thing which is still missing. So let's first check this one. Let me put it in full screen. So here we have the ID, which is integer, not null, primary key, birthday date. Also, we can make this one non-null. We have also the email, and everything is compatible with our need, except for the role, which is of type varchar. So this is good. And also we want it to be not null, so we need to add the colon annotation here, and we add the nullable false. We can also do the same for the birth date. So we have here all the information that we need. So, but if you like using this colon option or this @colon annotation is optional, but be careful that you want to have nullable and non-unique attributes and so on and so forth. So let's restart our application and check the changes. I will open the database, refresh in here, and let me close this and reopen it again. Script and generate DDL to query console, and we see here that now we have the role which is not null, same for birth date, and so on and so forth. So like that, we changed, or like we fulfilled all the requirements that we have from our table or from our database. Now I want to show you something else. Here, let's imagine that I will just change the name of this class. I'm gonna call it employee class, for example, or employee entity, or my class, or my entity, or whatever. So what happens if I refresh or I restart the application? Let's see the changes here, and just put in mind that in this diagram we want to have the table with the name employee. So let's go ahead. The application is starting now. I'm gonna just refresh this and let's see the changes. So here we have this employee. It's just refreshing. It's just about my schema. Let me maybe refresh the whole schema. Okay, so let's just ignore this one. But here we have this table called employee class, and my table should be named as employee. So how can we fix this? All right, let's see the options we have. To fix this issue, what we can do is using another annotation called table. So this table takes a name attribute or name property, and here all I need to do is to provide the table name that I want to use. Now if I restart the application, but before that I would just want to clean up this. I will drop these two tables, okay, and then restart the application. So the application is started right now. Let me go ahead and refresh my schema. And we have one table, and the table is back to the original name. Yeah, the original name. All right, so here we can keep our class, or maybe or even we can rename it back to employee, but this will be prioritized. Like we have this table annotation with the name employee, so this is going to be prioritized. So if you want to update, or if you want to have specific table name, or if you already have the database already created by some other team, or it's another database that you can just use and you cannot create the tables, all you need to do is to provide this table annotation, and you can just give the any class name that you want to use. No, it's not over yet. It's not over yet. This is not the end of the video. There is something I want to announce. Well, actually it's not an announcement, but yeah, okay. So if you like the video, just go ahead and leave me a thumbs up, click on the like button, and leave me a comment what you want to learn next. And also I'm going to announce what will be the next video after this one. So in the next step, we will see, and I'm going to teach you how to create relationships and how to do the mappings between entities, like the one-one, the one-to-one, the one-to-many, many-to-one, and the many-to-many annotations. This is what we will see in the next video. So just go ahead, subscribe to my channel, and don't forget to smash the like button so I can continue on recording this video for you guys. Thanks a lot, and see you in the next video.